Hi everyone, welcome back to Java 1 for All. In this video we are going to talk about Executor. So basically Executor is a class that's going to help you. It's kind of an API, I would say, that is going to provide a way of decoupling the task submission from the mechanics of how each task will be run. So especially when talking about Runnable and threads, right now we have been using everything very low level. We did a little bit of changes when we're working in the concurrency here with the email delivery service. We were working getting the lock, let's say, in a little bit more abstract way than what we had before here in the thread package with conditions and the lock. But there is a problem that we may face if we are not careful. Let's say that, for example, we have a task, a runnable task, and each time user enters its name, and for example, you would like to do something, send to another API to do some checks, maybe credit check, and you just deploy. You have one user, okay, it creates one thread to do that credit check, 2 users, 3 users, and suddenly everybody starts talking about your program, and then you have like 1,000 users accessing the same time, and you are creating 1,000 threads for that. So this is one of the problems that can happen if you are not careful. So how can we do it? How can we then handle this, kind of have a thread pool? And this is one of the things that Executor API will do for us. So Executor test 01. Let's start creating a very simple runnable. A runnable that will basically just print the number and the name of the thread. Let's implement runnable. Implement the run. Ask here for a number. Private final num, int num. Constructor. And here, let's add printf, then %s. This will be the name of the thread. Start, then %d, and jump one line, %n, and then thread, current thread get name, and then the number that we just got in the constructor. Now let's put it to sleep for 3 seconds. And then I will copy this, Control C, all the way here, Control V, remove the number, and here you just say, hey, this thread finished. Okay, now into the executor test, yes, VM, and now it will come the part where we first need to define how many threads we want. So usually each processor, they have like cores. In my case, I have 4th generation i7. So if I ask here for runtime, get runtime at available processors, I will get 8 because of the hyper-threading. We have 4 cores, and then it will emulate or simulate to each core will have like a virtual core. So that's why I have 4 real cores and actually 8 here available for us. So technically speaking, I have 8 possible threads that can run in parallel at the same time. But the thing is, well, we have other threads running. The task manager, it's a very nice example. So we have like 8 available processes, but we have like 2,000 threads being executed now. So ideally, you have to be careful, because every time you create a thread, you are creating an object, and this object will require memory. This object will require some processing time. So in the end, thread is a object, and it's not just because you are trying to run things in parallel or like try to split the work that it will actually be faster. So this is very difficult to say. There is no precise math. Benchmark is, I think, the best option you have to check if writing higher number of threads is better than actually writing a lower number of threads. So now that we know kind of how many processes we can get, I would just leave this here for now. And I want like a fixed number of threads. I like a thread pool of 4 threads. So it doesn't matter how many runnables I pass, I want those 4 threads to be reused. And we have here Executors. So this is kind of a utility class that will help us to create some methods. For example, this new fixed thread pool. Basically, I can tell you here, I want 4 threads, and this will return a executor service. So from the executor service, we can now execute the runnables. But then when we do this, we are basically relying on the executor service to start, to schedule, to do everything. We basically just tell the executor service to execute the runnable, and after that, the actions, well, is up to the executor service. For example, executor service, execute, and then I will pass my runnable. That's the printer. Number 1. I have 4 threads. I will create 4 runnables. Now, the thing is, when I run this program, the executor service will not stop, even though all the threads finished their job. So I have to call a method to actually stop. So let's first execute and see how it works. So I have 4 threads in my pool. As you can see here, 1, 4, 3, 2. The scheduler is still the one that decides who is going to get started or not get started. So in this case, we have 4, and 4 of them were used. And the program finished, the thread they finished, but the program is still running. So how can we actually tell, hey, executor service, you are good to stop? We have to call executor service.shutdown. But that does not necessarily mean that it's going to shut down. Why? Because remember, the main thread is the one executing all of this. So the main thread will tell the executor service to run this, and this. And then if I add here, we are not actually going to see the result. Why? Because, well, the main thread is the one executing this, but the executor service still has some user threads running behind the scenes. So the time you call shutdown does not necessarily mean that's the time you will get the program actually stopped. You have this is terminated that you could kind of put in a while and check if the program is terminated. Okay, so what happens if I add more? Now I have 5 and 6, but I still have 4 threads. You're going to see the threads are going to be reused. So we have 1, 2, 3, 4, and then after they finish, for example, now 1 is getting the number 5, and then the thread 4 is getting the number 6. So it doesn't matter how many I pass here, I will always have these 4 threads kind of fighting each other to execute this task, but we are not going to create any more threads than what we have here. So if I pass this here, now I have 8 threads, but I'm using actually 6 runnables. So 2 threads are waiting. Since there is no use, we just finish. I'm actually not sure if it creates like all 8 threads or if it creates ad hoc. I'm not sure if there is a number of threads available in the pool. Yeah, I'm not sure if it creates 8 threads or it creates 6, and if I need more, it will just create more up to 8. Yeah, I have to check that out. So this is just one of the pools. We have other types of pools. For example, let's duplicate this one and comment this out. We have the fixed thread pool, but we also have the option to have only one single thread executor. So in this case, as the name implies, I will have only one thread. This thread is going to be reused, so it's not going to create a new one every time. You can see the name of the thread is always the same, so it will keep reusing the same thread over and over again. And the other option would be the cache thread pool. So what is this cache thread pool? Basically, this one, is not bounded, there is no limit, and it will create the threads as needed, but it's going to reuse the ones that were previously constructed. And after 6 seconds, if the threads are not used, they will be terminated and removed from cache. So you will see now, Ctrl-Shift-10, that it will just start all of them, 1, 2, 3, 4, 5, 6, all the runnables, and then they are going to finish. So I'm not sure here. This fixed thread pool, we have a new thread pool executor. I'm not sure if these will yeah, I will check later if there's a way to figure out how many threads we have in the pool. But this is it about the, well, at least an introduction about the executor service. So now you are decoupling the task submission with the task execution, and you are kind of relying more on Java to take care of things, which in the end may reduce the number of bugs. So I hope you enjoyed. Let's continue with more topics in the next video. Bye.